Well, hello, welcome back to our next step in the energy unit. I guess we'll put a heading on this. This is not going to be a real long one. I'm not really going to give you additional notes. I'm going to show you an example that I want you to copy down, sort of continuing with this theme of a puzzle to solve. It goes back a couple of assignments where I gave you a little puzzle, like a roller coaster puzzle. So this will be part 9. And just to kind of give you an idea of what we're going to do here. So a couple lessons ago, we worked little roller coaster problems, figuring out how much of each type of energy a roller coaster would have at different points. And the important things you needed to know were that the height is what determined the gravitational potential energy. So we used proportions, like if you were 5 times higher, you would have 5 times the potential energy. And we also needed to know that the total energy, what I call the magic number for each roller coaster situation, that number will be the same at every point along the ride, okay? The other third little thing was that the thermal energy is probably going to be increasing as you go, because as friction acts on the wheels against the track, you build up more heat, and that's what we call thermal energy. So now the difference is we're going to use the 2 formulas that we worked on in the previous lesson. So we have a way of calculating gravitational potential energy using mgh. I'm just going to jot this down here. GPE is calculated by multiplying these 3 things: the mass times the value of little g here on the surface of the Earth, which is 9.8, always 9.8. It's an easy number for students to forget. And then h is the height you are above some level. Typically we measure from the ground. The other formula we saw was kinetic energy, which is 1/2 mv squared. That's 1/2 multiplied by the mass of the object times the speed of the object squared. Okay, the only number that gets squared is the speed. You don't square the mass, you don't square the 1/2. So there's what we call order of operations in math class, right? That's really important. Okay, so let's take a look at this situation here. So I've given you some heights for a little car. And the other thing that's kind of hard to see on here, it's a little easier to see on the picture of the car here. The mass of the car is given right on the picture itself. It's 20 kilograms. 20 kilograms. I'm totally making these numbers up, by the way. These are kind of absurd numbers. And it starts with a height of 100 and ends with a height of 40. Okay. The other thing to see here is that the speed is given as 31 meters per second here at the end. All right. So I've given you some energy numbers: 7,000 joules of kinetic energy to start with, 5,000 joules of thermal energy to start with, and nothing is given down here, because you're going to be able to figure out these 3 numbers just based on what you started with. Okay. So again, kind of a little puzzle that you're putting together. So whenever you work these things, especially if you're working in my room and you're working on paper, I want to see all your work steps, okay? Even if you're not in my room, I still recommend you work carefully using all 3 steps of the process. So the first step in the process is to figure out how much GPE we start with. And that's because in order to do anything down here at the end, we're going to have to know how much total energy the system has, the system being the car and the track and everything else. So we need that number, but we got to fill in this missing piece here first. Now, in a different problem, maybe I give you the GPE and you have to calculate KE. Doesn't matter which one you're asked to calculate, because you have formulas for each of them. Okay, I thought I'd make this one a little quicker by giving you the kinetic energy. So GPE is the mass of the object, that's the 20 kilograms, times G, which is 9.8 here on the surface of the Earth, and then the height, which at the beginning here is 100 meters above the ground. So we would write a formula here, GPE, and I'm going to put, just so I can remember, at the start, because I'm going to have a GPE later on too, equals mgh. We write the formulas with symbols first, and then put the quantities in the same order that you wrote them in the formula. So since we wrote m first, we're going to put the mass in first. That's 20 kilograms, again, given in the little diagram. Sometimes it'll be written in the text of the problem. G is 9.8. Newtons per kilogram is the best units to use for that. And the height at the beginning is 100 meters. And then we grab a calculator, and we multiply those three numbers, and we get 19,600 joules. I always recommend you write commas in when you're doing it on paper, but a lot of times on the Google form I ask you to not include commas. Okay, so as we calculate that, let's write it in. I'm going to write it in red so you can remember what's been given to you in black versus what you had to calculate. So 19,600 joules goes there. Okay. Now the next step, to figure out the magic number for this particular problem, that magic number being the total energy of all the energies combined. Okay, so we're going to add together that number, 19,600, plus another 7,000, plus another 5,000. And that gives us 31,000. I'm just going to jot that on my figure here, 31,600. Have to have that number to be able to do the last part. Because the total of these three numbers here must be the same as the total that they started with up here. Now, they're going to be different numbers. One will be maybe a little higher, one could be lower. Maybe two are higher and one is lower or whatever, but they still add up to the same number. So what do we know here? Well, down here we're given the height, which allows us to find GPE again. We're also given the speed, see the 31 meters per second. That allows us to find the kinetic energy. We do not have a formula for thermal energy, so it will be the rest of the energy that makes a total of 31,600. So we have to do it last, okay? So I think I'll just divide my paper down here so we can do some work for the second part of the problem. So GPE at the end, MGH, same M, same G, but different height, only 40 this time. So 20 kilograms times 9.8 newtons per kilogram times only 40 meters. And we multiply those together. And we get got to hit my buttons right on my calculator. 7,840. 7,840 joules. I'm going to write that in up here. Okay. Just kind of filling in, again, pieces of a puzzle, if you will. Now we're going to do a kinetic energy calculation at the end. 1/2 mv squared. Most common mistake I see on this is people putting the wrong numbers in for the wrong letters. You have to know that m represents mass in kilograms. Don't put in a height for that. Don't put in a 9.8 for that. Put in the mass in kilograms. And 31 meters per second. And that number, this is another thing I see. People forget to square that number. Okay? So we'll multiply those. Now on my fancy calculator here, can you see this? Let me hold it a little higher. 0.5 times 20 times 31 squared. I don't want to square the whole thing. I don't want to hit equals and then square it. 9,610. Make sure you can get that number as well. That's joules also. 9,610. Write it in. Again, I'm writing in red as I calculate things. All right, now the last one. Again, we don't have a formula for this. The idea of getting this one is to use the conservation of energy. Energy is conserved, or it stays the same as a total. Even though we obviously have a lot less GPE, we have a little bit more KE, but we must have more thermal energy for it to add up to the same number that we started with. So I've run out of room on my paper. You would turn the page, but I don't want to turn the page. So let's just go over here. So the thermal energy at the end is, now there's no formula for it again, so what I'm going to do is just write out 31,600 joules minus 7840 and minus 9610. So I've subtracted the two parts that I know, and the rest of it, or the leftovers of that, is thermal energy. Just doing subtraction there. It gives me 14,150 joules. 14,150. And you can always go back and double check yourself that these three numbers do add up to 31,600, just like they started. And they do. Okay, let me zoom out a bit so you can see the whole page. All right. So there's what a typical kind of puzzle looks like. Again, very similar to what we did before, except we're not just getting the energies. We're working with the formulas for kinetic and potential energy to do that. Okay. So yours will probably look a little bit different than this, but the pieces and the parts and the process, very, very similar. Okay. As always, if you have trouble, ask for help. Even if you're not in the classroom, you can ask for help electronically. And hopefully everything goes okay. And we can fix any problems that you do have. Okay. All right. That's it for now. I'll let you get to your work.